Let us revise some important formulas in information theory chapter. So the first one is joint probability pxi comma yj is given by pxi into pyj given xi. Similarly, we can write pyj into pxi given yj. So here you can remember this. If it is xi, then here it should be yj. Here yj, then it should be xi. So another important point is row wise elements addition of joint probability matrix will give the input symbol probability, and column wise elements addition of joint probability matrix will give the output symbol probability. So this is important when you're solving the problems on computing the different types of entropies and mutual information, as well as it is important when you calculate or when you do the problems on computing the capacity of the channel. And then hx formula. What is hx? Hx is entropy. Entropy means average information or average uncertainty. You can say information as well as uncertainty. So hx is summation I equal to 1 to m pxi log to 1 by pxi. It is average uncertainty of input symbol x. Average uncertainty of y is j equal to 1 to n pyj log 2 of 1 by pyj. Then this entropy hx given y is summation I equal to 1 to m j equal to 1 to n pxi comma yj log 2 of 1 by pxi yj. So that is, this is all, h is always average. So average, h is information or uncertainty. So average uncertainty in x after you have observed y. Next one is hy given x. So summation j equal to 1 to m I equal to 1 to m j equal to 1 to n pxi comma yj log 2 of 1 by pyj given xi. So that is average uncertainty in y after you know x was transmitted. Then joint entropy, that is average uncertainty or average information in x and y taking together. So pxi comma yj log 2 of 1 by pxi yj. So in every equation this joint probability is same. Change is in the log term, log 2. If it is x by y, then pxi yj. If it is y by x, then it is pyj given xi. If it is x comma y, then it is pxi comma yj. Now mutual information is hx plus hy minus hx comma y. Also it is given by hx minus hx given y. So mutual information, we can, from this equation we can also physically interpret it as ixy, or mutual information is uncertainty in x remaining after you remove uncertainty in x having observed y. So hx is uncertainty in x. When from this you subtract uncertainty in x after observing y, that is nothing but ixy. So ixy is nothing but uncertainty remain in x after you have observed y. For example, if you want to know something about a particular person, and you are asking it to the third person. For example, you gain the information about him that he is living in xyz city. So you were unknown about that person, but after talking with your, for example, your ex, and you want to know uh, z, and you are asking it with y. So y has given you that z is living in particular city. So you have uncertainty about z, but somewhat uncertainty is removed by asking the question to y. What uncertainty is removed? That he is living in uh, dash dash city. So this is the same, that uncertainty, mutual information is uncertainty still remain in x when you subtract the uncertainty in x after observing y. So here I have given you the one example to understand this. Ixy is also hy minus hy given x. So this is also easy to remember, hx minus hx given y, or hy minus hy given x, or hx plus hy minus hx comma y. Now hx comma y is hx plus hy given x. So don't get confused with this formula and this formula. In hxy there is plus sign, and ixy there is minus sign. So that is hy plus hx given y. So here if it is x, it is y. In this case it is y. If it is y, it is y only. So these are the some formulas which you require in solving the problems on the computing mutual information, and what different types of entropies and capacity of the channel.